Hello, everyone, and thank you for joining us. My name is Gisela, and I will be the host for today's webinar. Before I pass it over to our speakers, let me cover a few housekeeping items. At the bottom of your screen, you will find multiple application engagement tools. You can adjust their size and position to optimize your computer screen. To expand your presentation area or maximize it to full screen, simply click to the arrows in the top right corner. If you have any audio or video issues, you can find answers to some common technical questions located in the Help widget at the bottom of your screen. Please note that the copy of today's slide deck and additional resources are available in the resources list. Please have a look and download everything that you may find useful. Also, this webinar will be recorded and sent via the email you registered with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We are here to answer you live via the chat throughout the presentation, so don't hesitate to reach out. In case we run out of time or we didn't manage to answer your questions, we will make sure to follow up later by email. Now, I would like to introduce our speakers. Today, we're joined by Matt Mickle. He's the Director of Automotive and Semiconductor Solutions in Jama Software, with a focus on providing solutions and consulting to the unique needs of the market. He has over 10 years of experience working with hundreds of Jama Connect customers on their requirements and system engineering processes as a consultant, and moved from the US to Europe in 2017 to help start and build the team at Jama Software's EMEA headquarters in Amsterdam. We are also joined by Jeffrey Clem. He is a consultant at Jama Software with focus on automotive and semiconductor industries, previously served as an IBM Distinguished Engineer and a member of IBM Academy of Technology. Before joining Jama Software, he held roles at Bellcore and Sun Microsystems. Jeff is the primary author of RFC 3253 and specification lead for JSR 147. He earned his BA in Applied Mathematics from Harvard and a PhD in Computer Science for the University of Colorado. And with that, I will pass it over to Matt.
Thank you, Gisela. Today, I will spend some time introducing the topic of product line engineering and some of the benefits as well as challenges that come along with it, especially pertaining to the work that you need to do in Jama Connect. I will then hand it off to Jeff, who will walk you through a practical way to implement product line engineering into the way that you work within Jama now. We will then sum up and take away any questions from the audience. So without any further ado, let's jump right into it. What is product line engineering? Well, there's multiple definitions floating around for product line engineering, but for the purpose of this webinar, we're going to stick to something that makes sense from our perspective, which is a focus on engineering for a family of products with similar features, components, or modules as a single product line in order to leverage the commonality and variability, minimize the duplication of effort, and maximize reusability. There's lots of examples of what a product line could be. It could be a series of vehicles, such as what you see here with the J series, where you have different models that are part of a single product line. It could be military vehicles developed for different roles. It could be versions of software that are built for different types of consumers, like your light user or your expert user. Could be a line of appliances with different sizes or capabilities, like an oven or a dishwasher. It could be a line of laptops with different sizes, different amounts of memory, and different amounts of CPU. Or for semiconductor, it could be configurations of IP for a chip family. So lots of different ways that you could have a product line. And with many of those ways, you need to think about product line engineering. So what are variants, and how do you manage those variants? So along the same pathway, we will refer to variants as basically anything that would vary from product to product within a product line. And that could include some of the examples below, like different features, premium services, levels of performance, different components that you might have, kind of like what you see on this ad for the J Series Turbo. And when it comes to variant management, we'll simply refer to this as the process or the technique that helps us manage and organize the variants. And this could be through one or multiple of these different modes that you see below, or it could be something that's not listed there. Okay, so what are some of the benefits that we get from product line engineering and from variant management? Well, one is product line engineering enables organizations to create a product line architecture that allows for a systematic reuse of components. This can be components, modules, assets, and those are across different products within a product line. This promotes efficiency by reducing redundancy and the need to recreate similar functionalities for every product. Another way is by reusing existing components and assets, organizations can significantly reduce their development cost. Product line engineering allows for economies of scale, as the investment in creating a core set of assets can be spread across multiple products, leading to cost savings in the long run. With product line engineering, organizations can also streamline the development process by leveraging those existing components and architectures. This means faster time to market for new products, since development efforts are focused on creating unique features rather than rebuilding common functionalities. It also helps ensure consistency in the products across your product line. If you reuse well-tested and validated components, the likelihood of introducing defects or inconsistencies is reduced, and that leads to higher overall product quality. As the market demands change or new technologies emerge, product line engineering provides a framework that allows organizations to adapt and evolve their product line more easily. This enables the addition of new features or the modification of existing ones without starting the development, right from scratch. Product line engineering also supports efficient configuration management, therefore allowing organizations to define and manage variations in products through configuration rather than by creating separated versions or desynchronized copies of content. It simplifies the task of handling different customer requirements or market-specific adaptations. It also makes the maintenance and updates more manageable. Changes or bug fixes can be applied to common components, and the updates can then be propagated to all the products in the line, ensuring that each product benefits from the improvements without having to undergo individual modifications. It also helps with mitigation of risks associated with product development by relying on well-established and proven components. Since these components have been used and tested across multiple products, the likelihood of critical issues arising is reduced. So let's talk about some challenges then with product line engineering. Let's say a company starts out with a single product and then begins to build variants of that product, therefore turning it into a product line. Well, as the number of variants and variation between them grows, the ability to manage them becomes more and more challenging. When a change is made, it's important to assess not only the impact of the change within the product where the change is made, but also in any products that are part of the same product line. If the change is against the common requirements, then the decision is needed on whether they need variation. New versions or configurations of components of a system will also need to be thoroughly reviewed with regards to how they interconnect. This becomes even more challenging and complex when considered as the product development data moves from one development application to the next. Throughout the supply chain, information about progress and change needs to flow and be collected in order to see overall status. It's very difficult to collect and understand this data with only a single complex product, and that increases exponentially with variation.